Thanks for watching and welcome to the most important rule in PDEs, which is the chain rule. So here's a setting, and I leave this for a diagram. So, suppose f is a function of two variables, z and w. So suppose f is a function of z and w, where z and w themselves depend on x and y. So where z is a function of x and y, and w is a function of x and y. So just as a diagram, f depends on z and w, and z depends on x and y, and so with w. And the question is, what are the derivatives of f with respect to x and the derivatives of f with respect to y? So then what is, or what are, partial f over partial x and partial f over partial y? And the cool thing is, you get the answer literally by following the chains. So what it is, df over dx becomes df over dz times dz over dx, the first chain, plus df over dw times dw over dx. So in this case, df over dx is df over dz times dz over dx plus df over dw times dw over dx. In other words, once again, to find the derivative of f with respect to x, you look at all the chains that end with x and you follow them. See, this is not precisely why it's called the chain rule, because you follow the chains. And you may notice it is an extension of the single variable chain rule, where you at least formally just cancel out the dz's, but you have to do it for both variables because f depends on z and w. And you add the plus because the z contributions and the w contributions are independent. Now, what about for df over dw? It's the same thing, but you look at all the chains that end with y. It looks a bit like a monster, but df over dy now becomes df over dz times dz over dy in this case, and then plus df over dw times dw over dy. And as promised, we'll use that many times in PDEs, especially in our next video, which is the coordinate method. But I do want to illustrate this with a small example. So for instance, suppose in this case f of zw is z sine of w, where z is, I believe, x squared y, and w is x cubed, I believe. And what we want to find df over dx and df over dy. Df over dx and df over dy. In other words, what we really want to find is the derivative of x squared y sine of x cubed with respect to x and with respect to y. You may ask, why not do it directly sure, if you have a concrete formula for f, you can do it directly, but it's more useful for theoretical purposes when you do things abstractly. So now, let's just follow the chain rule diagram. So once again, f depends on z and w, and z depends on x and y, and w depends on x and y. And so in this case, df over dx. Once again, you follow the chains that end in x. So same thing. So that's df over dz times dz over dx plus df over dw and then dw over dx. And now what this is, that's z sine of w with respect to z, and then z is x squared y with respect to x, and then plus z sine w with respect to w, and then x cubed with respect to x, which in this case becomes sine of w times 2xy, and then plus z cosine w, and then times 3x squared. Which now you can just plug everything in, so that becomes sine of x cubed times 2xy, and then plus x squared y, cosine of x cubed times 3x squared. You can check that's the same thing you get by plugging in z and w first and then differentiating with respect to x. Now, we have done the x derivative, next up the y derivative. So for df over dy, once again, you look at all the chains that end with y. I know it's kind of scary, but in that case, we get df over dy. Okay, the first chain is the z chain, so df over dz. Hope you're not getting too dz. And then dz over dy, and then plus df over dw, and then dw over dy, which now becomes z sine of w with respect to z, and then zy, so x squared y with respect to y, and then plus z sine of w with respect to w, and then x cubed with respect to y, so that becomes sine of w, if I'm not mistaken, and then times x squared, and then plus z cosine of w, and then times 0, so this whole second term disappears, and you're left with sine of x cubed, and then times x squared. And once again, this is one of those things where practice makes perfect. And I do want to say it's so important that even Nick Jonas sang a song about this when he says, "You got me in chains," because of the chain rule. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.